Good evening, everybody. Can you hear me? I judge from the impending silence that you can. Welcome once again to the George Square Lecture Theatre, particularly on what is a rather wet and windy November evening. At this time of year, there are two unmissable series. On Saturday nights, we have Strictly Come Dancing on the BBC, and on Tuesday evenings, we have the Our Changing World lectures. Last weekend, the nation's favourite weather forecaster, Carol Kirkwood, was voted off Strictly. But I'm very pleased to say that we have Dr. Meriwether Wilson here to give tonight's lecture. Dr. Wilson is a lecturer in marine science and policy here at the University of Edinburgh, focusing on science, policy, society interface of transboundary marine ecosystems and services, particularly in international waters. She gained a degree in botany and zoology, a master's in environmental science, and a PhD in the built environment, looking specifically at the urbanization of coastal regions. Her current research explores emerging challenges in coastal marine governance and marine ecology regarding infrastructure developments in nearshore and offshore marine areas. This includes novel habitats of marine built environments, coastal adaptation, mitigation and policy, marine ecosystem services, and importantly, access and benefit sharing. Meriwether has many years of research and teaching experience with the University of Washington and the University of Edinburgh, including launching a new MSc in Marine Systems and Policies, for which she is the Programme Director. She's a member of the IUCN World Commission on Protected Areas and has recently given many invited talks, including at the joint EU-IUCN Guadeloupe Conference on Biodiversity Climate Change for the EU overseas territories and regions. The ocean is a medium for transport, for drilling, for trawling, and in the past for dumping industrial, domestic, nuclear, and ordnance waste. And it continues to be the drainage system for terrestrial runoff. As we discover new targets and technologies for exploiting the marine environment, there is an increasing pressure to achieve this in an ecologically sustainable way. And to explain how we balance blue growth and conservation, please welcome Dr. Meriwether Wilson.
Okay, can you all hear me all right? Is everything working? I'm very wired in the mechanical sense. So I'm going to start with a question to the audience. So does anyone have a clue as to what this image is that is very blue that you were all staring at? Just yell out if you think you know what it is. A whale. It is a whale. Very good. And it is a humpback whale that I took snorkeling in Polynesia one year. And there was a male, a female, and a young one. And they were so close that this is, all of my pictures look like this. I don't have a picture of a whole whale, just parts of whale. But I think it's a nice visual metaphor for what I hope will be an interesting journey this evening as we try to navigate and swim our way through the oceans from the near shore to the offshore and back. So I'm actually going to start dangerously with where the last talk left off. The last talk focused largely on number 4, quality education and learning for sustainability. But, and you'll notice there's quite a lot of development goals. Apparently there were only going to be 5, and they decided to go with a full 17 as the citizens wanted. And there's one way down in the bottom, number 14, curiously called Life Below Water, which is kind of an odd name for oceans and coast. But it's a nice way to start because, as you can see, it's really about why do oceans matter. They cover 3/4 of our planet. 90% of the water on our planet is ocean, and 99% of the habitable area that many species live on is also oceans. The 40% of the oceans have been affected heavily, as far as we know. There may be more, there may be less. They have an estimated value of $3 trillion per year, which is about 5% of our global domestic product. They contain at least 200,000 species, and here they say it may be up to millions. That's a pretty big gap between 200,000 and millions, which tells us we don't know about a lot of things in the ocean. Global capture and fisheries are very part of the ocean's productive capacity, which up to 80 million tons, yet the subsidies are discouraging recovery of fisheries that are on the brink of collapse for many stocks. And as you're probably hearing about more recently, the oceans absorb about 30% of the carbon dioxide that we produce, as well as other animals on the planet as well. And it provides a critical buffering system for us to survive. It's the world's largest source of protein, especially for people in poverty. And the marine fisheries, directly or indirectly, employ over 200 million people. I think last count there were maybe 250 million people in America. So it gives you a sense of scale. So I always like to start with this slide because it keeps me meaningful and mindful about the ocean. And the ocean is not just a vast sea of blue. It's a huge topographic undersea world. So this is a map you've probably all grown up with in one form or another of the seafloor, which gives an impression of the ridges, the seamounts, the continental shapes, the margins. So the connectivity between land and sea is really deeply illustrated in this picture. And you get a sense of the various plate tectonics, spreading ocean ridges, all the things that are kind of the exciting hotspots of biodiversity now really start with this geological basis. And on the surface, if you could imagine the surface being overlaying here again, where you have the ocean currents moving everything around. And then there's a whole three-dimensional element about the oceans that very few of us have had the pleasure to go through in terms of the water column. We spend most of our time on the surface. So this is just to remind us again about the connectivity of the planet, in particular the land and the oceans, and the different cycles that are vital for our existence and our survival: water, carbon, and us. So again, this slide I think is fantastic because it shows the different currents that really dominate the way the ocean circulates around the globe. And everything, whether you're a sailor or whether you're looking at marine debris or whether you're a tuna or whether you're a whale, you're very dominated by these currents if you're spending your life at sea or in sea. And again, this slide is quite basic for those of you that have had second-year oceanography here at Edinburgh, which I recommend you to take if you haven't. But it just gives a nice sense of the overall depth and layers and complexity of the ocean and the attempts to give names to these layers, this three-dimensional element. And where it says high water on my upper left, that's basically where we spend most of our time, right there on the surface. But we're increasingly fishing in particular deeper and deeper and having other activities and units going further and further down aside from just exotic submarines. This is an important slide. We'll have this a couple of times about the high seas. And so there's dry land where we are now, again on the far left, and the continental shelf, or the 200-mile area, which is what is the perimeter further out for a lot of our land masses. And most nation states own or have exclusive rights out to 200 miles from their margins. Now, it gets complicated when you have margins of a landmass going in and out, so it's not a straight circle around Britain, for example. Scotland has an interesting sort of wedge going out to its EEZ, where a lot of our marine protected areas are. And then there's more complex geomorphology and actually physics and math involved to figure out the slope, but you can actually potentially claim further out if you're a nation state, which is part of what's going on in the Arctic at the moment. So this is a nice picture of Europe, and I'd say in a general way, I think Europe, for a large region, has an incredible diversity of seas that is, I think, rarely appreciated in terms of going from the Arctic through the temperate down to the subtropical, further down off the coast of Portugal. So it's an amazing place for biodiversity, for looking at climate change, for a whole range of environments and ecosystems. So it's quite special. And I think this is also quite special that we have the EU and some of the regional elements that tie these seas together, both for their connectivity and their diversity. So I'm going to very quickly just kind of go through Ocean 101, which is probably not necessary, but it's fun. It keeps us imagining we're somewhere else other than here on a bleak winter night. So we'll quickly cover islands, shorelines, the deep sea, and ocean areas. But we're going to start with where I grew up, which is the Chesapeake Bay, and little tiny spot right here is my home for a long time. But it was an amazing place to grow. It's a very diverse area. Washington, D.C. is up at the top. But it's also like many estuaries. You get a lot of rivers coming into the bays with a lot of pollution runoff, as our host was saying a few minutes ago. So it's very important for wetlands, waterfowl, fishing, but it's also a very impacted area because of the numerous rivers and in many cases, many cities that are around typical bays and estuaries. And this is going further down, also where I spent most of my summers, Cape Hatteras, North Carolina, partly to just make a personal touch, but it shows you again, off the east coast of the US, this idea of the continental shelf and the slope and the drop-off. So that law of the sea diagram that I showed you, you can see right here in this particular coastal margin. And these are a series of long, skinny islands that are about 100 miles long going this way, and then another 100 going down that way, that are largely protected national seashore. And it's the easternmost point, actually, of the U.S. sticking out into the Gulf Stream, and it's where the Gulf Stream and the Labrador Current meet, so it's quite a dynamic area. Pretending that we were going further and further off, we're now in what I might call the deep sea, but you can see how it's connected to the land. And this is an image that I think really brings home the biodiversity and geodiversity of the deep sea. And you just look at some of the words, mud volcano, bottom waters, seamount, pockmarks, all kinds of mysterious, funny words that we're slowly starting to discover more about, and we're also at the same time starting to realize there's a lot of mineral resources and other possible values to humans in this area. So this is an area of a lot of activity on all levels. And these are some of the creatures that live in the deep sea or on the seamounts. That's a crinoid sort of creature on there, the red one. And this is an area where you have these sensitive, fragile, soft corals, basically. And then down here on the brown left corner of the screen is the a trawled area from fishing. And they tend to take a very, very, very long time, years to recover. And that's an area of active research, trying to get an idea of the recovery time for these deep sea systems. So my favorite habitat, by the way, atolls and archipelagos. And this is a picture that the head of School of Geosciences took on a research. He was on a microlight flying along looking for corals to go and core to do some climate change work on them. So you can see a very interesting system with the ocean on one side and lagoons on the other. And it's very typical of what is in, say, the Maldives, parts of the Cook Islands, parts of Polynesia, Marshall Islands, and Kiribati. And so some of the challenges, as you can appreciate, for these low-lying atoll island systems, they're very vulnerable to climate change and sea level rise in particular. Many are over only a meter high, their highest point. A lot of overfishing, both in the lagoon and in the offshore. A lot of their large blue areas are leased out for large-scale tuna fishing and other large-scale fish. Habitat lost of this very narrow rim. Managing the governance and the scale, you have very tiny island land masses with very large ocean areas, and that's sort of not a way of governing that we're used to. But there's a lot of opportunities, energy, minerals, fisheries, tourism, and biodiversity heritage. And previously, certain parts of the world in Polynesia and the Marshall Islands were also used for a lot of military testing in the past. So they have a very complex history, physically and politically. A few more things. And now they're increasingly proposed as marine protected areas, which we'll talk about in a minute. So just that's what a high island would look like, and the atoll can form around the edge once the high island sinks. And this might remind you of someone you know who was also once studying here, Darwin, and he figured out the whole evolutionary idea of the atoll geomorphology and the high islands slowly over time subsiding and leaving this ring of atolls without ever having gone on a journey or a voyage. And later, when they did drilling in Anahuac in the 50s, it proved his theory right. So these are just some of the kinds of plants and animals that you would see if you were on one of these islands. Coconut crab, I think that's a booby, a little young booby bird. And jumping now to other types of nearshore and intertidal environments, these are kelp forest, which we do have a lot of here in Scotland. You have them off the coast of California. Most of your big temperate subtidal systems have these vast kelp areas that are sort of like underwater trees. They're large framework species for hosting fish, as you can see, and other species that live in and around them. seagrass meadows, which we have marshes here, and we also have some seagrasses here. This is Posidonia oceanea, a protected species in the Mediterranean, and this is actually looking down in the Balearic Islands, and you can see the dark shapes are large seagrass beds, and there's a close-up. So they're very important for coastal protection, and increasingly they're being studied as areas of carbon storage. And they're rhizomatous plants. They're actually flowering angiosperms, and they lay down root systems that, as they decay, they build up, or build down, shall I say, over time, down to, say, even 6 meters. So that's a lot of carbon that is actually buried in the seagrasses. So when you're dredging or trawling, you pull a lot of this up. Coral reefs, which is what a lot of us think about with the marine environment, very vibrant, very colorful, very diverse. They're probably one of the more threatened habitats that we're looking at. They're close to the land masses, the tropical land masses, and they're very susceptible to temperature change, overfishing, eutrophication, nutrients. And this is a close-up of a coral. So if I just go back for a second, imagine, say, that red coral there, which is actually a living colonial animal. And this is a close-up of the coral with its polyps, basically the coral mouths. And so it's one colonial animal with lots of mouths. Imagine if you guys were all connected somehow with all these mouths. Then inside each of the little tentacles are these brown spots. And the brown spots are photosynthetic algae called zooxanthellae. So actually, the coral animal needs the zooxanthellae inside to help provide food and energy. So when the coral gets too hot from coral bleaching with rising sea surface temperature, it kicks the algae out and it becomes white. And that's basically what coral bleaching is all about. So they also have cold water corals. We have a lot of cold water corals off the coast of Scotland and Norway, and we're finding more and more and more. So they're a kind of a, you can see all the spots up there, the red dots. So they're another very framework species that support habitat for lots of others that are very vulnerable to trawling in particular. So this is just a big school of crevalle jackfish in the Gulf of Mexico, just giving you an idea of the density and the scale. And you can imagine if a large purse seine or a tuna net, or some kind of a net came along and scoops this up, you can get a lot of fish at one time, which is good and bad. So just migratory species are critical for the ocean, and it's not the ones we see that often, although on the west coast of Scotland we have quite a few species, including whales, dolphins, sharks, rays, turtles, that some of them span the entire realm of the ocean in their life history stage. It's the humpback whale. I don't know if it's the same one that I showed you at the beginning, but might be. Manta rays, this is off Chagos. So we all take it for granted that the ocean is vibrant, valuable, and beautiful, and I think most of us probably would not agree, but it's also very important for fisheries, for food, for oil, for gas, shipping, minerals, travel. So the ocean and all the habitats that we've just swam through are trying to do all of these things at once, or we are trying to ask the ocean for all these things at one time. So I'm just going to do a quick little run through of time in terms of the evolutions of our thinking and knowledge and our values and the practices that we've arrived at today. So this is a very old map of the world currents, and you'll remember the one I showed you before. They actually understood them pretty well just from their sailing and shipping days of the 1700s, the 1800s. And as many of you know, in the 19th century, the first expeditions were just really voyages for transport and trade, with various impacts on the remote people that lived in these small remote islands. And that same time, there was a fascination with ocean and seascapes. It was mysterious, it was wild, it was primordial. So there was quite a confluence of sort of military expeditions and trade and transport, and the whole kind of support of it that was going on in different countries, expressed in all kinds of different mediums. So it's really a very vital era of exploration and explanation. So Charles Darwin, who I already mentioned, the voyage of the Beagle, which is where he finally did get to see his coral reefs. And then we have Albert Russel Wallace, who was a colleague of Darwin's and focused more on the Indo-Pacific area, and Wyville Thomson and John Murray, also these gentlemen are connected with Edinburgh as well, and they were on the Challenger expedition, which did some of the first deep sea studies ever. So Edinburgh, ironically, has a very well-established, at least marine legacy at this point in time. So this is the Challenger expedition, and these were the first kind of verification that the deep sea is not just mud and ooze and brown slime. So it was quite, it changed the entire thinking, basically, of what the ocean benthos looked like from this expedition. And then in the early 1900s, you'll see these marine labs there, SAMS, which is the Scottish Association of Marine Science, up in Oban, which we're affiliated with. There was quite an explosion of marine science, marine description, trying to describe and collect what was going on. So we kind of went from exploring to a description phase, and in particular the intertidal rocky areas, because they were very accessible. During the, in parallel with the things going on in the early 1900s with wilderness areas on land, and many of you will recognize John Muir's name, who is from Dunbar, nearby, here in Scotland, but he's famous for helping really push the wilderness areas that are now so famous in the US, such as Yosemite. But that same discussion of, should we have wilderness, or are these resources there to be developed and used for humanity? So that conversation was actually even going on the marine side, and but it was still in a very descriptive capacity, and it really wasn't until Cousteau came on the scene and helped demystify, and through the silent movie and other books and things he's done. And then some of you may be aware of Rachel Carson's trilogies, and she is more famous for something called The Silent Spring, which is about pollution and chemical pollution. But she wrote a series of books about the sea describing it. So there was quite an interesting kind of background thinking. And then over time, this is actually Seattle from the 1850s to a graphic of the area that's all built out now, and that's a classic Google shot. And this could be any major industrial port in many parts of the world that over the last 150 years have been basically drained the wetlands and been turned into flatland for shipping and transport. And that really, I think, is part of what started the Renaissance, a kind of environmental renaissance for the US, especially in light of the non-Renaissance in the US at the moment. But we had the Endangered Species Act, the National Environment Policy Act is really where environmental impact assessment as a process started gaining traction, and that led on fairly quickly in what was then became the European Union to have the Habitats Directive, the Birds Directive, and a whole series of other directives at the same time. UNCLOS, I think, was originally 1982, and then has other ratifying elements after that. Biodiversity Convention was not until 1992. So there's quite a range of things that were going on in the 70s and 80s that are part of our discourse and our shaping and our governance today. Now, the other thing that's emerged and that's part of the lexicon today, and that's quite a contested term, is this idea of ecosystem services. And this picture is supposed to make it look simple. It usually makes it look more complicated, but the idea that various aspects of ecosystem functionalities provide benefits for society. I like to think that they provide benefits for the other ecosystems, such as a kelp forest is providing benefits to the fish that live and reside within the kelp forest. But it really, what happened is Robert Constanza, who was an economist at the University of Maryland, he did a kind of back of the envelope estimate of what the value of the mangroves, the kelp forests, the wetlands, the marshes were in terms of the coastal protection they provided, the fisheries they provided, the food they provided, the shelter, all of these systems, and put some economic numbers on it. And it was a bit of a wake-up call that actually losing these systems is going to be more expensive than, and replacing them with hard infrastructure than protecting them to start with. So that's where this word natural capital came from, the idea that this part of the planet, all of these parts of the planet are our capital. They're our investment that you don't want to overspend. And this whole concept was brought to light through something called the Millennium Ecosystem Assessment that really made it a more popular term, made it more accessible, and had different scenarios of a sort of utopia Earth, a total built-out Earth, and different horizons if you took these different valuation scenarios. And this is where a lot a lot of thinking, a lot of discussion, a lot of modeling, a lot of mapping, a lot of GIS work is going into trying to quantify all of these ecosystems and then trying to figure out how much they're economically worth. And now they're moving in the direction of how much are they socially worth. Because you'll notice in the previous slide, there was aesthetic and beauty. So, going to a gorgeous coral reef might be, you just want to be there because it's beautiful. And now you might have to pay a lot to get there. So they often do a lot of travel cost analysis to try to estimate how much something is worth to someone. So, but this shows you some of the other values in terms of food for biomass, fiber, nutrient cycling, what else is up there? Flood retention, erosion control, coastal protection. So here in Britain, especially in England, where there's a lot of erosive coast, there's a lot more attention going into flooding both from the rivers and the larger storm systems that are coming from the sea. So that's often the intertidal systems are probably one of the easier areas to grasp this concept. And this is also, they're now trying to apply these same concepts or questions really to the deep sea. So we're into systems we know very little about and trying to put some kind of an economic and a social value on them. So people make matrices like this and fill them with colors and question marks, and it's extremely simple looking, and it's really at this kind of starting point of an indication of what we do and don't know. So if you think about a forest, you would be able to fill in all those boxes with lots of numbers. Where deep sea marine environment, it is very much a blank slate. So this is something, you can't see it. I couldn't even see it when I zoomed into my computer, but it's worth knowing about. Over the past 10 years, there was something called the Census of Marine Life, a really, really special international global attempt to describe everything, from the tiniest microbe to the largest whales on the whole planet. So it's a massive recording of marine biodiversity through different universities in different places. And it just gives a snapshot of the incredible diversity and dynamics that's out there. So it kind of brings us back to this idea of awe and wonder with the ocean ecosystems. But then you read a paper that someone gave me this week, and I was like, wow, that's an intense image. And it was probably my visual metaphor when I was thinking about this talk. Although it's taken time frames, I was only thinking about the last couple hundred years. This particular image, you'll see there's dinosaurs and whales. So it's starting with, I can't quite see it because of the screen, but let's call it hundreds of thousands of years ago, and then we're quickly into agrarian systems, and then we're into urban, and then we have I suppose these are our urban Edens. And right now in the marine environment, we're very much on this side of here with the wave and tidal. I'm not sure what these floating structures are there. Oil and gas, that's probably a floating city. There's the overfishing. So it's a powerful image, but it's also a bit of a, it's maybe portrays things a little bit more horrible looking than I think they really are. But the idea of defaunation, that we are losing our plants and animals at a pretty rapid scale. So in a way, the idea of living with a changing ocean is really, I think, what we have to be thinking about. Our ocean's changing, oceans always are changing, but they're changing at, if you look at the difference in the rate, all of the yellow is only 100 years. So the rate of change is incredibly different than it was for the previous millennia. So in a simple way, just these are some of the high-level, big picture threats to the ocean and impacts. So we've just kind of been through this journey of values and beauty, and then we see the different things that we're dumping, dredging, fishing, extracting. We're basically putting things in and taking things out in terms of our own agency and direct impacts. And then we'll talk a little bit later more about some of the global, truly global phenomena such as ocean acidification and climate change that are a byproduct of the CO2 absorption. And invasive species, and that's a very interesting area of research because species have always been moving around and migrating. But we decided it's a protected area for this species. And if the species go out of it, what happens? Is it still a protected area? Do you make another one over here? So it's got the taxonomist and ecologist and a bit of a muddle about what to do with these species that are moving, and even fisheries fish that are moving from, let's say, Iceland up to Russia. Well, those were Iceland's fish. How can we just let Russia have the fish? Maybe we have to prove that we have rights to those fish too. So the idea of static ownership over very dynamic species is kind of playing out and being tested as range shifts are happening faster than we had previous governance systems to align them with. So these will be familiar pictures. These are from the IPCC, the Working Group 2 on adaptation and mitigation. Particularly adaptation, they have a whole series of chapters. There's 2 actual chapters on the ocean. There's one on low-lying coast. There's one on islands. So it's a nice way if you really want to dig deeper into this. But basically, there's quick slides showing sea surface warming. We know the ocean is warming at quite rapid rates, in particular the Central Pacific, the red blob, as it's now being called, up there. And that has an impact on the coral reef systems for, as I explained about the zooxanthellae that live inside the corals is just one example. And these are the different sea surface temperature estimates from various global models. So it's pretty warm, it's 16 degrees today, November 10th. But that's taking a very one-day view. So you can't do that. You have to do this over thousands of years through different measurements past and then also the instrumental data forward and using models. But it does give you an idea of what's going on. And these are the other 2 topics that you hear a lot about, basically the ocean becoming more acid. And this affects carbon corals, as we already saw. It also affects ctenophores, which are a little... well, that's a type of comb jelly, and any calcareous mussels, any calcareous organism in the ocean are very affected by that, and it'll affect the whole sort of different food chain relationships as well. And this is more of a typical picture, what I was just referring to down south, with regards to dealing with flooding and sea level rise, or more extreme weather events, of which there's a lot of research going on to that now. But this is all part of the large-scale systems of the oceans that we're thinking about. And that's just another example, just to show you in kind of a cartoon, the different relationships that are going on with the everything from putting too many nutrients in, which gives you dead zones, depletes the oxygen in various areas, to overfishing, to some of the changes in temperature and acidity as well. And this one is interesting. I was just mentioning about the range shifts. And not only range shifts, not only are the location of where fish and other marine organisms changing, in many cases the size is changing. Part of that's due to overfishing, but part of it's changing size in order to adapt. And this particular slide is one of my favorites because it not only, the intention of the slide in the paper was to illustrate synergistic. And there's not impacts in isolation. They work together, usually in negative ways. But the flip side is perhaps we could try to reverse some things in positive ways. So I took a look at this and just thought, well, perhaps we could think of the early 1950s, from 1900 to the 1950s, as the era of dumping. It's when you put everything in the ocean, and then that later we're still kind of just coming out of the era of exploitation, taking things out, fisheries in particular, and then the climate is basically the next era, this truly global change. So it's a nice visual metaphor for the different things that are going on in time and space. And just to kind of connect that, this is the the European seas that I showed you earlier in terms of their diversity and the sea surface temperature change that are just going on within the European seas alone. So they're very good places to basically study and watch, because you have everything from the Mediterranean, the Black Sea, all the way up to some of the Arctic seas, in terms of getting a handle on what is true change over time in the ocean systems. And this is a concept that anyone that's in my classes knows I speak about from time to time, the idea of phase shift. When you've altered something to such a point that it's not the same system anymore, and you probably can't restore back to that system. So this paper was about fishing, and then it also applies very well in our coastal wetland systems and all the different things that are going on at one time, so it's just a concept. But in the same paper, this is from 2001, it's quite interesting that they show for different groups, the kelp forests, as I showed you a picture of, coral reefs and estuaries, what was a typical food web of those systems, and then having people as part of that food web in the way that we've changed the relationships, not only of what we eat and what we're catching and what we're fishing, but how that has knock-on effects for other aspects of the system. So it's trying to take that kind of model that I just showed you before and try to work it out in a more realistic way. What is our true impact on these systems as everything, in particular overfishing, but all the other types of aspects that we're doing. So this is just a quick snapshot of a place in Jamaica, the Discovery Bay Marine Lab, and in the 1980s you had a lot of these staghorn corals, partly hurricanes, partly urchins, but basically the corals have died off because they've been over-harvested in terms of fish that were grazers, and you lost the urchins at one point, and the seaweed has just taken over the corals and smothered the corals. So the same kind of polyp that I showed you, it no longer was able to breathe. And you have a system that looks like this now, and it would be very hard to get back to that system as you had before, even if you use artificial reefs. And there's a whole kind of technology of using fake reefs, big reef balls, or sort of giant structures trying to basically help a reef get started. But it takes many, many years for these to develop. Similar, as I showed you earlier, the trawling impacts on cold water corals. So corals, because we can see them, they're visual, they're vibrant, they're our kind of early warning systems of these scales of change that may not return to what they were before. And this is just taking that same metaphor a step further. This is Malé in the Maldives, which is the capital of the Maldives, where my group has a field trip, and we start here. You can walk around the island in about 2 or 3 hours, but it's an extreme example of what that beautiful coral atoll that I showed you at the beginning of the talk, how you can build that out. And they're having sea level rise issues there because they're low-lying atoll, and one of their solutions is to build more malés. But it's the idea that the built environment will be the solution to offset sea level rise and pressure. And a lot of countries don't have choice, but it's an interesting example of how altered a system can be. So I think we'd have a phase shift here. Now, just marine thinking globally, where plastic is again becoming an increasingly aware issue. We didn't know about it so much until remote sensing has helped us, and ironically, even the search for the Malaysian plane revealed, because they were doing a lot of large-scale seafloor mapping that had not been done before, and has documented how much plastic is out there, which had not been previously realized, because most of the time you're not on the surface of the ocean, or a lot of it sinks down as well. And this is, I'm not going to play it, but this is actually a nice slide of the Pacific Gyre and these large areas of plastic that are miles and miles and miles wide that just sort of get caught up in the same gyres that I showed you at the beginning of the talk. And they call it the journey of trash, from 8 months to 6 years. And so you read reports about people that are going sailing and different things, and you do navigate through a lot of trash. But I can say in Scotland so far, you don't see as much. So, you know, it's kind of gloom and doom, and you think, oh, now what? And this year, an organization called the Global Ocean Commission, they came out with basically a call to restore and recover the ocean. So it was interesting, they weren't saying, let's protect it, let's try to restore and recover it. So there was a kind of tacit assumption that it's declined. And it's declined for these reasons, which I've already mentioned to you in terms of the overfishing, the various technology is both our friend and our enemy, in that it's letting us have access to see, demystify environments, but it's also letting us extract in ways that are probably faster than we should be doing until we know more. Fish stocks, the climate change we already talked about, and the challenge of high seas governance, because a lot of the high seas, all of the high seas, are not owned by any one body, and we'll get to that in a minute. But at the same time, it's a nice report. It's all downloadable because they have a whole series of trajectories out and the different things that you can do, from creating a high seas regeneration zone, trying to deal with plastic, illegal and underreported fishing, governing the high seas, and a UN development goal. Well, they've achieved that one. We now have goal number 14 that we saw at the beginning of the talk. But none of these are easy tasks. Conceptually, they're intuitive, they're on the right track, but they're very hard to operationalize. So, because I mentioned, part of what you need to do is know what's out there. And so this is a side-scan sonar, and then it's also showing the different cold water corals. So the relationship between, say, oceanography and industry should be ever more close in terms of sharing knowledge, sharing data, because you really need the high-end kit to get under there and explore and see a lot of these environments. And previously, industry operated in the oil and gas environment, say in the 70s, in a less data-sharing world. And so there's a lot of knowledge that we don't know. And I think that's starting to shift, especially with the marine energy that's coming online. There's a more open, transparent climate for that. Just kind of sticking with various technology-based themes, the slide on your left is a series of 4,000 tags that were put on various turtles, whales, mola fish, and tracked over 9 years. And so it's a fantastic image of our true the fauna print. I don't think I've ever said that word before, fauna print, marine fauna print. Now this is our ship print, and this is just over, in 1 year, from 20 ports. So it's just a kind of interesting visual dichotomy of the true relationship of things that are going on in the ocean surface and the two different, very different user groups, you might say. So this is another thing where I like this juxtaposition where there's a gannet diving down for a fish, and that's reality. And this is our marine spatial planning. It's very two-dimensional. We're starting to move into more three-dimensional modeling, trying to grasp this dynamicism in water. But it's just this extreme juxtaposition between the dynamicism of the ocean and our mapping and our two-dimensional way of zoning and organizing principles. So that's kind of, that whole background has led into what's the new buzzword, blue growth. And I don't have it on this slide, but we might ask ourselves, is blue the new green? And I mean, did we ever even get the green? Have we got green on the terrestrial sides yet? Whatever green means, it's supposed to be this sustainable nirvana that I don't think we've achieved yet. But now the idea is we can have blue growth in the ocean without even realizing what's going on there. So some of the blue growth horizons it's being very driven probably by marine energy is probably one of the biggest drivers behind blue growth and the various installations that are going on out there. So ecologically, it's quite interesting. These structures are growing new habitats. Are they good? Are they bad? Are they creating invasive species? So you're basically introducing lots of texture and scaffolding into subtidal sandbanks that weren't there before. So it's actually like large-scale experiments, but then you could say, well, is that good or bad? And so it's pushing the envelope on marine spatial planning and governance further and further offshore to accommodate this growing world of different ocean resources, from energy to deep sea mining to other aspects. So on one level, it's pushing. We do now have a higher push to understand and demarcate and demystify the ocean, so ostensibly we can use it better. And this is a report that came out by UNEP, United Nations Environment Program, last year or so, I've forgotten the date. And so this idea of goods and services, ecosystem services, is sort of in the conversation here. And what struck me was this visual metaphor of a cornucopia. It's just like, great, there's this vast, endless world of ocean stuff for us to enjoy, eat, play with, and that it's got this, we're back to this idea of limitless. That there's plenty out there. I'm overstating the case, but it's interesting, the imagery, the words, blue growth, this kind of the lack of limits that's in the jargon right now. The EU has a Blue Growth Initiative. They have actually very good websites. There's even a Marine Spatial Planning Directive. There's not a Blue Growth Directive per se, but there's the EIA Directive. There's a series of directives that are coming online on the back of this, trying to, the EU has one of the world's largest ocean water body resources, especially if you take all the overseas territories into account. So there's a lot of energy opportunity, a lot of military opportunity, a lot of fisheries opportunity within the EU realm. So there's kind of the conservation side is still going on, but there seems to be more of a drift towards this blue growth. And again, trying to have a balance of everything, as if that's what it really looked like. And there's a series of timelines and studies and books that you can watch this kind of progression from a more environmental limit approach to more of a blue growth approach. And the idea that if we can just zone it right, map it right, manage the time and space, we'll be able to have all these things in balance. So it's just like coastal zone management about 20 years ago, but now we're further offshore. And this, interestingly enough, is the Nature Conservancy, and they were one of the world's leading NGOs, starting, I don't know when TNC started, but I'm just going to say the 80s. And so again, like a lot of the NGOs, non-governmental organizations such as World Wildlife Fund, Conservation International, they were really the leaders of terrestrial and marine protection. But there's a program and a website called Mapping Ocean Wealth. So we see this terminology of wealth, of natural capital, this kind of accounting terminology going into everything. And on one hand, that seems quite pragmatic, quite interesting, and the idea that if it doesn't have a financial value or even a recreational value, it doesn't have value. So there's a dichotomy going on in these things. But I just thought it was interesting that even TNC has this kind of approach to mapping ocean wealth. And I mentioned marine spatial planning earlier. This is off the coast of Belgium, and you could probably have similar for Scotland, similar for, in particular, the North Sea. There's shipping lines, there's wind farm areas, wind farm leases, oil and gas leases, recreation zones, marine protected areas. So when you map everything that is trying to happen in a given area, this is what it looks like. So imagine you are a ship and you're trying to navigate your way through this, or you're a developer and you want to do another wind farm lease. So it's quite an interesting time right now in terms of the different demands and goals for what's going on, even just within these 200-mile or less territorial and EEZ areas. So the new term is marine spatial planning, but you notice it's spatial. There will be temporal elements as well. So there's a lot of work. If you all want jobs, learn GIS, learn marine spatial planning, learn laws, and this will. So again, it's very much like what was going on in the coast and the terrestrial systems 10 and 20 years ago. But we know a lot less. It's very hard to go walk the environment like you might be able to do with a forest. And to make things even more interesting, this is the international picture of policy for managing ocean systems. So you'll recognize some of these players: UNCLOS, Law of the Sea, FAO, Food and Agriculture Organization, various UN bodies, UNESCO, international, other ones. So they're even struggling to figure out who's doing what on various transboundary aspects, on various pollution aspects, on overfishing, on invasive species. So there's a lot of dialogue going on between these groups, and they're very vital to ocean marine environments because of its transboundary nature. And everything, as I said, is very hard to actually, even on a map, it might look you've got zone A, zone B, but that's not the way the systems actually operate. So there's a slightly more simple version, and we're moving towards areas beyond national jurisdiction as well, beyond the 200 miles, which you'll see in a minute, and UNCLOS, which I said was started in the 1980s, and it really deals with the seabed and the sea surface. I have to be careful, there are 4 international marine lawyers sitting right there, so I'll probably get it totally wrong. But anyway, it's become a more powerful instrument than it even was before as we try to figure out how to map the seabed and how to manage the marine space. It's still missing the water column in its governance remit directly, so that's going to be an interesting challenge. And regional fishery management organizations are becoming more and more important. UNESCO has always been quite special in that it has protected areas or identifies areas on the natural side for biodiversity, for geomorphology, and for beauty. It's the only convention I know of that has beauty as one of its requirements. So in the Convention on Biodiversity going on, CITES dealing with different international trade aspects. But these are critical so international governance is critical to marine systems, even at the national level. And part of this is, we saw this before, so we're over there at the baseline, and that's a complicated concept of where you decide these boundaries extend from, and if the baseline shifts because the amount of the water has moved inland, or something has dried up, or the ice is frozen, or the ice is melted, that baseline shifts. So that has a ripple effect all the way out. But basically, the EEZ back is of national interest, and the area, the extended seabed, is actually in the law of the sea to be an area of common heritage for mankind. So it's quite interesting that the seabed is common heritage for mankind, but the high seas fisheries is more on a common property resource, who has the best boat to get the most fish faster. So it's a very different paradigm. And one of the things that's been going on, as we're able to, thanks to remote sensing, thanks to underwater surveillance, thanks to taggers, such as what we saw in the turtles before, we're having larger and larger marine protected areas. So that's intrinsically good. Managing to monitor and enforce them is quite a challenge, even for countries like the UK, Australia, and the US, because they're so large and they're so vast. This is where remote sensing and remote surveillance is going to be playing a large part. This particular slide says 2.2% of the ocean is protected. I saw a more recent one that said, I think, 3.14%. We're in the sort of 2-3 range of the ocean being protected. And if you say, well, what's effectively protected? It's really keeping illegal fishing out. It's really keeping illegal dumping out. It's really being a biodiversity refugia. Is in this sort of 0.01 type of range. But now this is a map of one of the things that's going on now, and you'll see in the next table, and you probably heard about Pitcairn a few weeks ago, a UK overseas territory that is now the latest largest MPA. So there's sort of this race to have ever larger MPAs. And so I have my table that I've been making for a couple of years. So I've just added Pitcairn and then the Kermadec Islands in New Zealand. So it's very, very exciting, actually, that these various nation states are trying to put large envelopes of care and stewardship around huge ocean bodies of water. It's particularly relevant for the small island states, because that's mainly their sovereign resource, is the ocean realm. But it's quite an interesting, as we're having blue growth and trying to extract more fish, more deep sea mining, more wind farms, more wind energy, at the same time, we're having larger and larger marine protected areas. So again, it's a little bit deja vu, probably of the early 1900s, when there was this, should we have wilderness areas or forest only to extract? So I feel like there's this kind of same tension going on at the sort of larger level. With the EU collectively, and you combine all the various territories that have different legal and political legacies and relationships, it actually would add up to be the largest sort of what could be managed ocean space in the world. It's not that simple, but it's quite, and there's a series of projects that the EU and IUCN are working on small island systems in particular, and some of the fisheries aspects scattered throughout the globe. And some of these are temperate, some are tropic. So it's a way to try to get to scale to some of these projects. And similarly, Conservation International, another large NGO, they're working with the seascape idea of connecting different countries that might have currents that connect them, or a series of islands. They may be individually owned, but they share a seabed or share fishery stocks and resources. So trying to take a larger scale, dynamic transboundary approach to marine conservation, not just having a circle around an island. And this is going back to the slides I showed you in the very beginning with the atolls and the small islands. So right now, to be a nation state, you need to be able to stick out of the water. You have to have some kind of elevational rock, but it has to be a habitable rock, not just a rock. You have to be able to have a government, you be able to support society. You have to be able to do these things to exist as a nation. And so if some of the low-lying states lose that existence capacity, and Tuvalu, they all have to move to New Zealand, for example, they potentially lose their sovereign existence and their physical right to the undersea volcano, the undersea marine areas. In contrast, and this is a little bit controversial, in the Spratly Islands in South Asia, the Chinese government are doing the opposite. They're building up islands, and they're basically taking the same laws and creating a way to establish habitable presence and structures that have a governmental capacity. So you have these two creating islands on one hand to extend your seabed, your sea area, your sovereign rights, and then you have other countries that have far less resources that have been there for centuries on the verge of vulnerability to sea level rise. So it's basically a case where, in particular, the Montevideo Convention and the UN Law of the Sea and the Convention and Protocols on Refugees, which are not really about environmental refugees, they're outdated for the current climate issues that various island nations are likely to be subject to. You could apply this to lots of other places too in terms of the climate refugee situation. So it's an example of the need for legal governance and legal intentions to keep up with what's actually changing in a biogeographic way with ocean systems. And these are just some pictures of these super big MPAs. So they are remote, they are big, and it's still going to be hard to protect them from sort of foreign fishing fleets and mineral extractions. And some of them are no-take marine protected areas. Some are multiple use, where you might have mining and fisheries, not in the same place. The New Caledonia Coral Sea is a multiple use one. The Chagos, as you know, started as from a UK point of view anyway, as a military area. And there's a kind of controversial discussion about Chagosians wanting to go back and settle. How long were they there before? And, is the marine reserve to keep people from moving back? So this is a case where you have a very interesting relationship with history and land. The Sargasso Sea is quite special. It's really established for the Sargasso eels that migrate across, as well as turtles and this large mass of Sargasso Sea. So this is an example with Bermuda being a single island state, having a large EEZ, but also trying to work on it with other countries, such as America and some of the Caribbean countries. So this is kind of going through the process now. But there's not an instrument to establish high seas MPAs yet. So you're still really framed with the EEZs of a nation. This is the latest one off Australia's coast. So extending, we already know how big the Great Barrier Reef is. And now you can see the Coral Sea area that's being established. So it's exciting, but it's also curious, really. How can these be functional? They're so big in terms of the traditional thoughts of a marine protected area as being primarily for biodiversity conservation. But it's also kind of an interesting. Now, I mentioned the high seas several times. So everything that's dark blue on this map is high seas. That means it doesn't belong to a particular country. Everything that's light blue is basically the EEZ around the various country margins. So I don't know how much of the sea is high seas, 70%, more or less. But so that's a vast area of ocean that does not have one country able to govern and claim it for any particular reason. It's a very interesting area. They're working on an implementing agreement with the UN Law of the Sea to try to have some kind of high seas mechanism. But what would that be? An international body? Would other countries join in? So these are the areas of the seabed, which is mainly being exploited or explored for mineral resources at this point in time, where countries can claim out to their seabeds. And this is the different things that can go on with the high seas. So it's, with the high seas freedoms and the relationship between the terrestrial or the continental and the offshore areas. And just going to wrap up, there are some very exciting things going on, something called EPSAs, which are ecologically or biologically significant areas, not easy to say. And it's kind of, the genesis for this is in the Convention on Biodiversity, but they're looking for things like seamounts, unusual marine areas that are either quite special, they're rare, they're threatened, they're diverse, they're representative habitats, similar to what we did with the Habitats Directive and the Marine Special Areas Protection here in Britain about 10 years ago. But as you'll see from this map, very, very large areas. So it's not like these are more just sort of, this area has lots of seamounts, or this area has lots of things, and it takes deeper studies to go further into them. But it's a kind of early priority setting around ecological features, not around political ownership areas. And the next thing that's kind of in the pipeline led through FAO, and it's dealing with vulnerable marine ecosystems, so for deep sea trawling. So there are measures in place now trying to get deep sea fishing to be off limits to various vulnerable marine ecosystems. So these are instruments that will work in the high seas, even though that's still challenging and difficult. And so these are some of the things, if you're going to do bottom fishing in the high seas, they're working at different kinds of regulations to try to make that less impacting. And then just back to the Global Ocean Commission that we saw before, and their 8 goals, which creating a high seas regeneration zone, having some kind of accountability board of a healthy ocean. How do you define a healthy ocean? Getting into illegal fishing. So this is sort of the big moves that are going on at the various international to national levels now. And then we're back where we started. Thanks for your patience. I know it's been long talk. Again, why the ocean matters. And you might see these words in a little bit different light than when you saw them at the beginning of the talk, I hope. I think number 14 should be really big. And then I went through the number 14 goals this morning, which are quite wordy, and I tried to get to essence as to the main points of them. So last week we ended with the SDG goals for, in particular, education. Education would apply very well here. I'm sure Pete would agree, but some of the themes we've already seen: reducing marine pollution, protecting coastal ecosystems, which we've seen a lot of that with the EEZs, ocean acidification, ending fishing, conserving at least 10% coastal marine area. That 10% number has been there for a long time. every 10 years we say 10%, and it's still not there. Fishery subsidies, that's a really needs a lot of digging into. I alluded to the challenges with the small island states already, improving ocean health, biodiversity. And one of the other themes that's emerging through the discourse is it's not just the sort of large-scale industrial beneficiaries, but the small-scale fishers and other resource people, and the whole aspect of poverty that a lot of coastal communities are in. And then the need for these, making the UNCLOS and the other international laws have more flexibility and more ability to be the instruments to handle some of these transboundary aspects. So we're back to Scotland. So that's all. Thank you very much.
Hi there, thank you very much. We've had a little bit of interesting news here recently where the Scottish Environmental Protection Agency looks as if it's about to abandon its own monitoring of industry. I may be incorrectly summarising this, having last year condemned, I think, more than one site a day. And this includes salmon farms and so on. So, and I wonder, could you say anything about your experience in your studies of the relationship between, let's say, government or NGO monitoring and industry self-monitoring?
Yeah, that's an interesting one because, for example, that's on the monitoring side, and even at the earlier stages, say the environmental impact that might have been part of getting a permit to put in an aquaculture site or to do some sort of infrastructure. The way the EIAs have traditionally been constructed are that the developers can acquire and pay for the EIA report. So there's an internalization deeply built into the system. So the idea of self-monitoring is intrinsically good if there is some kind of credibility and check. And then, so I would say if SEPA can do that, they are the ones that do the checking. And then you have the NGOs kind of checking on the back of them. So it can be redundant and repetitive. So clearly it's best if everyone can understand what needs to be monitored and why, and then it's done on a more of a common sense basis. And SEPA is also, they're dealing more with the pollution that's coming from land into the sea areas. So they actually draw a line at 3 miles and hand it over to Marine Scotland. But so I think the idea of having citizen science, NGO monitors coming in, it might be what's needed in some cases, but you probably need it at all levels. You want the operators to understand their impact. You want the government bodies to have that oversight capacity if need be. And then if it can be turned into the monitoring, in some places even turned into education awareness activities, depending on what you're doing.
How much of the change in Chesapeake Bay is due to deindustrialization? 30,000 manufacturing facilities have disappeared in the last 15 years.
That's a really good point. And is that because of economic downturn that they've deindustrialized?
It all went to China. It all went to China.
It all went to China. Okay, so it's economic transfer, technology transfer. So there's a lot of paradoxes. So you might have lost the economic engine of various towns and cities around the rivers and estuaries of the Chesapeake, so there's going to be fallout issues there socially. But I have heard, and this is more through family rumors, that there's more oysters, there's more ducks, it's more vibrant, things like that. I worked on the Black Sea for over 5 years before and after the Soviet Union change. And from 1991 to 95, which was pretty much after the change, and everything was stopped. You know, most of the economic activity in that region was on hold until things reorganized. And there was an amazing comeback of geese and fish and biodiversity in these coastal margin wetlands, even just in that time. But it was only because there was an economic turnoff of the polluting sources. So, but that's a good story. You want to then use that as a chance to try to, you know, if the industry is going to come back, how can you have it come back with more ecologically aware requirements? So there's some kind of accidental stories that bring things back. But I think the Chesapeake in particular has had a lot of academic, government, NGO work trying to monitor it. It's a very monitored place, just like North Sea is here. So that's a good question.
I'm just more cynical. I do think that serious studies have to be made of the benefit of NGO, the mitigation industry, as
Yes.
I call it, and the actual and other things that happen. So in the case of Chesapeake Bay, you have a natural experiment.
Yep, exactly.
You
We
can
do.
map the failure or the benefit of the mitigation
Yes.
industry, because it's had a very long lifetime,
That's right.
against the almost immediate benefits of turning off the industrial machine.
And that's where I didn't end with one of my usual taglines, is this need for coastal living laboratories. So we are doing these large-scale experiments, for example, with the wind farms and all the structures that are going in. You know, if you reframed the conversation from the beginning as a large-scale experiment for at least, you know, the first 2 or 3 units or situations that you could somehow monitor, not just for compliance, not just to see if it's creating negative, just to see what sort of change is happening so that you can design differently the next time. So it's a much more positive dynamic and a positive conversation. So that's where I think we actually had the Maritime Organization, MMO, from England come and talk to us, wanting to have a MMO academic relationship to try to broker that mitigation process with industry. So I think it's an interesting time for science and industry and the conservation communities to work together. especially this blue growth arena is, coming on board in a more transparent, expecting time than, say, the 70s with the original oil and gas.
The big issue to me, as a marine ecologist, is compliance. You know, it's wonderful to have large marine protected areas, or even small ones around the west of Scotland that are coming.
Exactly.
How in the hell will Scotland's compliance ever make people comply? Short-termism, profit?
Yeah. Well,
what's the answer?
Yeah. A lot of the research about compliance for things like fisheries in particular, and I don't know about the pollution, going to your question, is looking at a field called behavioral compliance. So it's almost the psychology of compliance, and how do you, kind of turn that into a positive psychology, and why would, someone not want to comply because it's too expensive, or they're getting some profit from it, or this or that. So trying to understand the kind of non-compliant rationales in order to see what actually needs to be fixed to change that conversation around so that it's a less polarized arena. And that's where, and if the compliance is laid out from the beginning, if it's consulted with stakeholders, which is also not an easy process, if it's more transparent, I think there'll be less reticent along the way. And this could be for, whale watching tourism, this could be for pollution monitoring, this whole understanding the issues by the different groups, and that it's more of a collective loss if it's not. So just changing that way compliance is considered. The same with the mitigation, looking at mitigation as an opportunity rather than a minimum.
I describe myself as a layman in this audience. There's a long article in The Economist magazine, the current edition, you might have read it, about El Nino. The main focus of that article is about the impact of El Nino on the weather and meteorological conditions in general over land, for example, the Californian drought. However, El Nino is an ocean phenomenon. Can you say something about the extent to which this is being studied to try and determine the effects on the life in the oceans, the use of the oceans, and perhaps you could also add the effect of melting of Arctic ice as well.
So on the science and the study of El Nino as a phenomenon, I can, in a very simple way, because I'm not an expert on that topic. You're sitting next to an expert, by the way. But there's sort of two directions going on. One is the more extensive instrumental modeling. So we have lots of weather stations in more places on ocean platforms. So trying to have global ocean observing systems, GOOS, out in the broader ocean, just to capture the data, to capture what's going on. In order to understand El Nino in time, in the past, there are a whole series of what are called archival records, such as corals, where you can drill through a coral and see the rings and understand the chemistry of the ocean that it was like when that coral grew. Same with tree rings and ice cores and mud cores. So there's a lot of science being done to understand the phenomenon, the expression of El Nino in sort of millennial timeframes, looking back and seeing how that lines up with our, 200 years worth of instrumental data that we have from ocean observing. And then they put these together into very complicated models that require lots of computing, which is your former arena, to try to make sense of it all. So there's a lot of sort of big science going on, from ground truthing in the field to that, to try to understand the dynamics. Trying to get that conversation into practice through building differently, planning your coastal properties differently, having a setback zone differently, planning for flooding, planning for extreme weather. That's more at the local council level, at the local planning level. And in places that are very developed, it's very hard to ask, a town or a port or a harbor to move. It could be done in new planning, it could be incorporated into new builds and new design. But for example, even on the inner Forth, up past Grangemouth, they're trying to consider removing some of the old failing seawalls and building restoring wetlands and having that as a kind of natural buffer that can handle the flooding from the upstream and the storm surges that might be coming from the land. So there's this sort of restoring or changing these coastal margins. On the deep sea, on the deeper areas, that's where, for example, let's say we have all these wind farms or other structures further offshore, ships moving around. If you could get them to be ocean observing, ocean collecting systems to feed back in. So we have a lot of platforms that could be used to gather that information and feed that back in. The Arctic ice, that one is a complicated one with its melting, and it has very important geopolitical changes and arrangements. And again, if the focus could be on the intrinsic interest and almost, shall I say, wow factor of what's going on with the ice changes as compared to, well, which country is going to win or lose, or which resource are they going to have or not have. So again, kind of like your question, if it could somehow have a slightly more higher moral high ground of intention, that would be really helpful. But I think the science is communicating with the industry could be better, and I think you've really hit something quite good on the climate change. And it gets hijacked, is what's going on in the States, but that's starting to emerge differently. So it gets politicized very easily as well. These big abstract things that seem abstract, they're real, like El Nino, they're very real, but they're sufficiently hard to get your hand on that they lend themselves to politicization.
In the UK, how would reorganisation of the Crown Estate and the way that is regulating things currently, how would that change blue growth in the UK if it went to community, local authority level? Yes,
that's something that's going on right now in Parliament. It's very, very interesting. So in the UK, as most of you might know, the Crown Estate owns most of the seabed, and it has for a very, very long time. And they basically are responsible for leasing out the seabed. And a devolved government, they don't, it's not all worked out yet, but that's part of the conversation of devolution. So there may be a sort of Crown Estate Scotland and Crown Estate England, but it's actually going further because they're going to be having, I think it's 11 regional councils around, or regional marine planning areas around the Scottish coast, say Argyll and Bute, I can't remember the names of them. So they're actually wanting to be almost a consultant to these new regional coastal marine planning bodies until they develop their own capacity. So I kind of made a joke about if you want to be in the right place for a job over the next few years, becoming a marine spatial planner is probably a good thing. So there's an interesting, and then the resources, say, of whether it's the wind farms or the oysters or the aquaculture, what the benefit flow will be, because it did just kind of go into Crown Estate Treasury and then into the National Treasury. So it's going to be devolved even further into these regional groupings. So that's all being worked out. And you can go to Parliament for some of the discussions that are open on this. So it's quite interesting because the Crown Estate's its own, it's a little bit different than you even have in other countries. So that's a really interesting situation. Thanks.
The image from the Maldives from others was quite striking. That combined with the Spratly Islands and the upbuilding there, is there a solution? Is the future for some of these low-lying atoll sovereign states, in order to maintain their sovereignty, to simply move up 3 floors
well,
and live?
It's probably a logical assumption. We're used to engineering our way, out of a problem. And it's probably going to be easier to get aid to do that. So it may be that more of these low-lying islands that have the capacity build up. And it may be that, the islands that are concerned and part of their message is their potential sinking, that may not happen. But you are still dealing with how, even in the Maldives, they've got, different islands with different numbers of people on them. And so they're creating something called a safe island strategy, where they're trying to say, well, this group of islands we're not going to rescue and build up. We're going to move the people from that group over to here and build up. So there's this kind of reorganizing, but that might seem quite odd to us to think, well, you're going to be told you have to move from this bit of Scotland to that bit of Scotland because we're going to turn this one into marsh and buffer. So they're doing kind of quite out-of-the-box thinking. I think all of the countries are, from building up to out-migration to, even changing some of the legal status of things. So it's actually quite an interesting area in terms of society, ecology, and engineering. Okay. Well, thank you all very much. It was a pleasure to put this together, sort of.